Hello everyone, my name is Shreyas. I am educated at Unacademy. So you can follow me on the Learning app as well. You can see my new set of courses on the Learning app as well. So this is a lesson about two-stroke engines. So two-stroke engines, they are differentiated into petrol and diesel engines. So two-stroke engines, they are actually now banned in India because they offer heavy combustion, but they are actually in our syllabus. So let's go on to it. And please do rate, review and recommend, share this lesson, and please do subscribe us on our YouTube channel. Thank you. So guys, welcome back. Let's move on with our course, Elements of Mechanical Engineering. Given my introduction already, please do find me on the Unacademy user platform, which is mentioned over here. Turbines, engines and pumps is the course which we will be looking at, and the lessons will be pertaining to this course itself. So the target audience for this slide will be engineering students, general audience who are interested in mechanical entities, people who are interested in machine related mechanisms, and automobile enthusiasts. So the learning outcomes of this slide will be two-stroke petrol engine, working of two-stroke petrol engine, the operation of two-stroke petrol engine, the two-stroke diesel engine, the working of two-stroke diesel engine, the operation of two-stroke diesel engine, as well as the comparison between the petrol and diesel engines. See the first stroke as a start of everything after a recovery. So this is a medical code. I just thought the stroke thing matches with the lesson, so I have put this code. So two-stroke engines, let's start with the first set of slides of our lesson. So two-stroke engines, these are designed to derive the power stroke during every revolution of the crankshaft. Hence, here the suction and exhaust strokes are eliminated. So two-stroke engines, it has only two strokes. So here the valves are replaced by the ports and the burnt exhaust gases are forced out either by scavenging pump system or closed crankcase system. A specific shape is given to the piston, reciprocating piston, which helps to prevent the loss of incoming charge and helps to exhaust the hot gases effectively. Hence, both sides of it are effective. Two-stroke engines are widely employed for small powers required for mopeds, scooters and motorcycles. These have single cylinder and three ports, namely the inlet, exhaust and transfer ports. But actually it develops 1.7 to 1.8 times the power, because some power is used for compressing the charge and also for scavenging. Hence they are not so suitably used. Most of the vehicles we use are powered with four-stroke engines itself. So let's move on to the working of two-stroke petrol engine. Two-stroke petrol engine, it works on the theoretical Otto cycle. So the downward stroke or the first stroke will be as follows. The spark is produced by the spark plug as the piston reaches the TDC. It is then represented by the point 1 on the PV diagrams. I will show you guys the PV diagrams. So there is instantaneous combustion which occurs at constant volume with increase of pressure and temperature, which is actually shown in the PV diagram. I will show that to you guys. And once the opening of inlet port is done, the compressed charge in the cylinder is ignited by means of an electric spark or a spark plug. As the combustion of fluid takes place, the burn gases expand and exert a large force on the piston, causing it to move rapidly from the TDC to BDC, that is the top dead center to the bottom dead center. So this force or power is transmitted to the crankshaft to the connecting rod. As a result, the crankshaft, it rotates at high speeds. The crankshaft then transmits the power through clutches, gears and other transmission elements to turn the wheels of the vehicle and causing it to move. Meanwhile, when the piston is pushed downwards push by the expanding gases, the movement of the piston from the TDC to BDC uncovers the exhaust port. A part of the burnt gases due to their own expansion escape through the exhaust port into the atmosphere. Further downward movement of the piston uncovers the transfer port, and it is also important to note that the downward movement of the piston, the air plus petrol mixture present in the crankcase is compressed by the underside of the piston. The pressure which is exerted in this causes the charge from the crankcase to rush into the cylinder through the transfer port. So you can see here, this is actually the exhaust blow down and this is actually scavenging. You can see this 1 to 2, it actually shows the first thing which is happening, the compression. Then the downward push and all these things. This is actually the ideal PV diagram. This is actually the actual PV diagram. You can see the spark plug over here, and it is actually 2-stroke, so there are only 2 strokes in this diesel engines. So let's move on to the 2-stroke petrol engine. Coming to the upward stroke, the upward stroke in this, the piston moves from BDC to TDC. Sorry, I am still in this thing only. So actually I had finished this remaining burnt gases. So yeah, once the stroke is completed, you can see there is a movement of 180 degree or half revolution of the crankshaft. So this is actually a 2-stroke petrol engine. You can see here the 2-stroke petrol engine. It is actually very compact in size and it looks very old types. Let's move on to the upward stroke. Sorry for interrupting that time. In upward stroke, the piston moves from BDC to TDC. As the piston moves upwards, it covers the transport port, thereby stopping the flow of fresh charge from the crankcase into the cylinder. Further movement of the piston, it covers the exhaust port, and thereafter axial compression of the charge begins. In the meantime, the inlet port opens and the upward moving piston creates a suction in the crankcase, due to which fresh charge from the carburettor is drawn into the crankcase through the inlet port. You can see here, this is actually I was telling no, inlet port, exhaust port, inlet port, exhaust port. This is actually a compound steam engine, which is also a type of 2-stroke engine. So you can see actually only 2 strokes are over here. So this is actually a working model. So I am showing you guys so that you can get it. You can see here, when the spokes rotates over here, it moves the piston. You can see the piston line here, which actually forces this thing to move again, where the transmission is processed here, or it is sent over here, the force which acts on this part of the engine. So once the carburetor draws to the gear through the inlet port, the intake of fresh charge takes place while the compression stroke is still in progress. And when the piston reaches the TDC, or the top dead center, the upward stroke is completed, and with this the crankshaft, it completes 360 degree or 1 revolution. Thus, 1 cycle is completed. It is very much used in light duty vehicles, as already said before, like mopeds, scooters, etc. Let's move on to 2-stroke diesel engine. 2-stroke diesel engine, it works on the cycle of upward stroke, the theoretical diesel cycle. So the upward stroke, the position of the piston is at the end of the combustion. The diesel fuel is injected just before completing the compression, and it starts burning at the end of the compression. This can be represented by point 1 on the PV diagram. I will show the PV diagram. The supply of the pressure and the temperature inside the cylinder are sufficient to burn the fuel. The supply of fuel continues. The high pressure gases try to push the piston downwards as at a constant pressure, and at a point the fuel supply is cut off. That is, after this compression thing happens from 1 to 2, at point 2 the fuel supply is cut off. You can see this is also a type of steam engine. You can see this also contains of only 2 inlets and 2 ports, that is the 2 strokes, upward stroke and downward stroke. And once the supply of fuel is cut off, the hot gases, they exert pressure on the piston, which pushes it downwards. Hence the work or power is derived. As a result, the burning gases, they expand adiabatically with increase in volume and decrease in pressure. When the piston uncovers the exhaust port during the downward motion, the burnt gases, they rush out of the cylinder to the exhaust port. There's a pressure drop, the pressure drops, and a little later the top side of the piston uncovers the transfer port. At the same time, the air in the crankcase is compressed by underside of the piston, and as a result the air rushes to the transfer port to the upper part of the cylinder and pushes the exhaust gases through the exhaust port, which is shown in the PV diagram through the line 5 to 6. Hence the crank, it completes half a revolution. So you can see here, this is a 2-stroke diesel engine. So this is how the whole thing happens. You can see here the ignition spark, it actually moves up, fills the spark, comes down, and the spark fills the whole cylinder. Now let's go to the downward stroke of the two-stroke diesel engine. It helps in the partly pushing of the exhaust gases through the exhaust port, and later the piston, it covers the transfer port and stops the flow of air into the cylinder. A little later the piston, it covers the exhaust ports also, after covering the transfer port, exhaust ports also, and it uncovers the inlet port through which the fresh air is drawn into the cylinder, and it's shown in the line 5 to 4 in the PV diagram. The actual compressing of air starts now, and it is followed by adiabatic compression until the piston reaches TDC, that is the original position of the top dead center, and the cycle completes, and hence the crank completes one complete revolution when going to. So this is, you can see here, the 4 to 1. This thing you can call it as the adiabatic compression, and from 5 to 4 it is actually the fresh air which is drawn into the cylinder. You can see a 6 to 1 exhaust, 5 to 6 blow down, 4 to 5 expansion. So let's have a comparison of the petrol engines and diesel engines. The petrol engines, they move on the cycle used in the petrol engines are nothing but the Otto cycle and the diesel cycle. The fuel engines are petrol and diesel. The fuel supply is by the means of carburettor to petrol engine and fuel pump and injector to diesel engines. The fuel control to the engine cylinder is by means of a throttle valve, and in diesel engines is by means of a fuel control lever. The charge contains a mixture of air and petrol, whereas the diesel engines contain only air. The ignition of charge is by means of spark plug, where it is self-ignition, and the range of compression ratio will be around 4:1 in petrol and 12:1 to 22:1 in diesel engines. So the exhaust gas pollution will be more in petrol engines, whereas in diesel it will be less. The thermal efficiency will be low in petrol as well as more in diesel, and the initial cost also will be low in petrol as well as more in diesel. The running cost will be more in petrol as well as less in diesel, and the starting of engine is very easy to start in petrol, whereas it is difficult to start in diesel, and it consists of a light construction which is easy to handle, and it consists of a heavy construction which is actually tough to handle. So thank you guys. Any questions, please do leave those in the comments box below. You can find me at the Unacademy user platform or the URL mentioned over here. And please do rate this course, review this course, and recommend this lesson if you have liked it. And please do subscribe or follow me on the Unacademy user platform for another set of courses by me. Thank you guys. Have a good day.